Example 6. The owners of a travel agency have determined they can sell all 160 tickets for a tour if they charge $8, which is their cost for each ticket. For each 25-cent increase in the price of the ticket, they estimate they will sell one ticket less. A business manager determines that their cost function is C of x equals 8x. The customer's price per ticket is P of x, little p of x, that's not profit, that's price per ticket, is 8 minus 25 cents minus 160 minus, or times 160 minus x, which comes out to 48 minus 0.25x, where x represents the number of tickets sold. Determine the maximum profit, the cost per ticket that yields the maximum profit. So, it's talking about maximum profit, so the first thing I'm going to focus on here is how do I make a profit function. Profit function that we've seen so far is profit function equals revenue function minus cost function. And up till now, the way we've done revenue is we take the price times how many things we sell, right? In this case, the price is little p of x, which is 48 minus 0.25x. Up till now, we've basically done fixed price costs. So something costs $37, something costs 25 cents. Now the price is changing depending on how many tickets are sold. All right? They're increasing the ticket price 25 cents. They're going to sell one less ticket. So 168 tickets is how many they were going to sell, right? Yep. Take one away, and then you add 25 cents to the price of the ticket. Right? So, you know, if they're selling tickets for $8, what it costs them, they'll sell them all. But if they start increasing the price, they're going to lose a customer per, right? And we also have X customers. All right? And that's customers who actually buy tickets. All right? So, looking at the revenue function here, if I take the price of a ticket, which is this, that's a decimal point there, and multiply that times the number of customers, this, that represents R of x. Okay, so if I take R of x equals the price per ticket, which is 48 minus 0.25x, multiply it times the number of tickets that are going to be sold, which is x, that gets me a revenue function of, I'm going to go descending order, negative 0.25x squared plus 48x. Multiplying x times both things. And again, I want descending order, so I put my x squared in front. Notice that the 0.25x is negative, so when I multiply, I get the negative 0.25x squared. The 48 is positive, so I multiply that times x, get the positive 48x. It tells us in the problem the cost function is C of x equals 8x. So the profit is revenue minus cost, so the profit function in this problem, big P of x, is equal to the revenue function, negative 0.25x squared plus 48x minus the cost function, 8x. And this time the cost function is linear, or it's a single object actually, so I don't have to put parentheses around it. Usually cost function is more than one thing, but in this case it just happens to be one thing. So minus 8x is sufficient. So my simplified profit function then, P of x, is negative 0.25x squared plus 40x. Okay, it didn't tell me to determine the profit function, but I can't do maximum profit if I don't do that, right? One other thing I want to warn you about, little p of x, big P of x, using the same letter to represent two different things. Make sure that you're very detailed in your work, that you write this one small, that one big, so there's a definite difference in what they look like. This profit function is going to be what I use to answer the question. You can see it is quadratic, creating a parabola. It's got a negative lead coefficient, which makes it turn downward, so I know automatically it's going to look like this, right? Yep. The vertex represents the maximum, and we have a formula to find the vertex. So we're going to do what we have been doing, right? X represents how many tickets we're going to sell, right? It also has the cost per ticket that yields the maximum profit. Cost per ticket is the ticket price. So they want to know the ticket price. So once I know what X is, I got to replace X over here to figure out what we should charge each customer to determine the maximum price, or maximum profit. So if we do that, The vertex value of x is going to be the opposite of b over 2 times a. Alright, which ends up being negative 40 over negative 0.5, which equals positive 80. A lot of times people see divided by 0.5 and they do half. Half of 40 is 20. Divided by 0.5, so it's 40 divided by a half, which is 40 times 2, which is 80. So be careful that when you get a half in there, make sure you do the proper operation with the half. I've seen people go the wrong direction with that. So looking at this whole problem now, just go full page here so we can see. The vertex value x equals 80. That represents what we're looking for from the number of customers. Right? That's not the maximum profit. That's how many tickets I'm going to sell, 80. Okay? I'm going to have more than that. Okay? I have the ability to have more than that, but I only need 80 because that's going to be my maximum profit. X is not the maximum profit. P of x, P of 80, this is big P of 80, is going to be negative 0.25 times 80 squared plus 40 times 80. Negative 1/4 times 6,400 is negative 1,600. 40 times 80 is 3,200. Add them up, we get a maximum profit of $1,600. The price per ticket, little p of 80, is going to be 48 minus 0.25 times 80. That's just 48 minus 20, right? 0.25 is a quarter, 1/4 of 80 is 20. 48 minus 20 gives us a ticket price of $28 per ticket. Now, think about profit here, okay? How much does it cost the company to get the tickets? $8. $8 per ticket. That's it. That's the end. That's how much it costs them. Whether they have 1 customer, 10 customers, whatever, each ticket costs them $8, right? They're charging the people $28. So every ticket's a $20 profit to the company, right? $20 profit times 80 customers makes $1,600 profit. Okay, the actual revenue, what they take in, if I put 80 in here, well, whatever 28 times 80 is would be the actual revenue. 8 times 80 would be the actual cost. 640 is the actual cost, so 2240 would be the actual revenue, but the overall profit is $1,600. So again, anytime you're doing one of these profit problems, simplify it down to what's the cost function, what's the revenue function to create the proper profit function, and then if you're looking for a maximum or minimum, hopefully it's quadratic. Linear functions don't have maximums and minimums. If they're flat, they just got one value, but if they're slanted, they go all the way up and all the way down. But parabolas turn, so they hit a bottom or a top. So if they're asking maximum minimum, we're probably going to be dealing with a parabola at this point.